Thank you. This is actually not the title of this talk. This is Python and video, what we can do for you. There was a little bit of technical difficulties, but that's settled now. So what I'm going to be talking about here today is our two tools, or a lot of tools, but mostly FFmpeg, which is a tool that people can use to transcode video and to connect video and to fix video. And I'm also going to talk about how you can use Python and the libraries that exist with Python to do awesome stuff with video. So first of all, a big thanks to Big Apple Pie and all of our volunteers, all of our sponsors. Thank you, Wayne. Thank you to everyone who's contributed to the open source tools that I use in this project. And a big thanks to Zuko, who wrote MoviePie, which I'll talk a lot about. And he's really done a lot, and he actually reached out to me, and he was very nice. So thank you, Zuko. So we're going to start really basic here, video files. Not a lot of people realize that what is inside your video file isn't just it's transparent. It's not just what makes up a video file is your container, your codec, and your actual data. So in your container, it has your headers, stuff that indicates what your codec type is, what library was used to write this file, what settings it has, its frames per second, its bit rate. All of the data about the file is contained in the header. And then the codec and the actual data for the file, that's the file itself. That's where the movie is. That's where what you end up watching. That's the group of pictures. That's everything. So there's lossy and lossless compression. Lossy compression means that we're going to throw out data for the sake of file size, and lossless compression means that we're going to keep all of the data for the sake of quality. We'd like to make sure that all of the data that this video had at the start is maintained in whatever the next rendition is going to be of this file. While lossy is something that you want to make super small so that you can send to anyone so that it can be anywhere. So in lossy and lossless compression, there's another subset of intra and intercoding. And intercoding is something like an H.264 file. It's a lossy compressed file that looks in different directions. No single frame in an inter file is a picture. It's always me missing some sort of data, and it relies on the entire string or the entire sequence rather of images in order to be made whole, because different parts of that image are being pointed to on different parts of the frame. But intra compression is like a JPEG or like a PNG file. It's something that from the start to the finish, you have the entire picture right there, and every frame is a frame on its own right. So that's obviously a much larger file size than a file that doesn't really have all the information in one place, and it's pointing all over. So here I talk about the different kind of frames. So iframes are the interframes. Those are complete images. Those are the largest part of the file that have all sorts of data in them that or mostly picture or mostly color data that you then point back to or then point that different files look at, that they read. P frames look forward. B frames look in both directions, and they look for different. They look for iframes that have the color data that they are missing. I apologize. It's 9:30. If I'm going a little bit too slow or too fast, or if I'm thinking that's not making sense, feel free to stop me. So which codec to choose? So I mentioned one. I mentioned H.264. I mentioned that because it's my favorite and it works a lot of places. If you've ever seen any video on the internet, there's a chance that you've seen an H.264 file. But there's more. There's H.264, which is not a free codec. It's got licenses attached to it that are not exactly nice. It's owned. It's proprietary. There's VPX, which is owned by Google, but is royalty-free and is, I believe, open source. And then there's Theora, which is a BSD-style free license. And the reason I chose these three codecs to talk about is because they're the main ones that HTML5 and that browsers really support. If you're trying to make a video element for your website, for whatever you want to do, you can use these, and you'll generally get a working video element out of it. So I mentioned FFmpeg. There's also Media Info, which is a great tool for inspecting files. If you've ever had an issue where a file will not work, or you're just like unsure of what's going on under the hood, you can use Media Info on a file, and it will basically just read out all the headers that I talked about at the beginning. It'll look at the container and just see what's in there, and it'll let you know, like, okay, this is what you're looking at, this is what's up with your file, and then it's your job to find out what's missing. So a little warning sign, FFmpeg has some pretty, so it's developed, it's got a pretty rapid development cycle. So you will find things that are on the internet that are not exactly up to date, that are not exactly correct, and that use flags that probably won't work on your version. So it's kind of dangerous to just go and Google, this is what's wrong, how do I fix it, and then use whatever they say blindly. So just a warning, always check the documentation. So this is what your basic script would look like. This script I can't imagine ever using, because all it does is take the original and make a copy exactly like it. And there's way easier ways to do that, but this is what it would generally look like. And these are some more flags that you can use. These are generic flags that you can use with almost any codec, that they'll always work. Another thing about FFmpeg is that because it's using all these different codecs, and all these different codecs are developed independently of the project, there can be different flags and different knobs that you can turn and different switches for different codecs. So a flag that will work for x264 might not end up working for VPX or OGG. But these are all generic flags that should generally work with all codecs. And so here is a way more useful example. This is just taking a raw input and making it into an x264 format, 24 frames per second. That is a typo. And, and that would be our output file. So another great thing that FFmpeg comes with is some really excellent presets. So they, when encoding video, you can have something that goes really fast that will encode it properly, but it will give you a pretty large file size because it's done a pretty quick job with it. Or you can do it very slowly, and you'll get a smaller file that is generally what you want to do. But FFmpeg gives you some excellent preset options for whatever you want to choose. Because if you're doing lossless compression that you want to then edit on, maybe it's okay if you just do it super fast and then have a very large file, but it's perfectly fine. That's what you wanted. And the tune option is for more specifically what's in the video, what you'd like to see in the video. So let's build some slightly more complex commands. So what this does over here, the pix format, that has to do with the color space of your video. Besides that, here we are, the raw video. And this defines the pixel format. There's RGB and YUV. RGB is video that is defined in the RGB color space, whereas YUV, Y is for your luminance, and UV is for your color, your chroma. So it's just two different ways of displaying video. And when going from the raw, we had to convert. Then here's 60 frames per second. Input file, super slow. This flag means no audio. This flag is your codec, your pixel format, your rate, and your output file. here is a dump that we can see from media info. It's showing that we got the right stuff. ABC, that's x264. Everything's looking good right now. Still looking gravy. This is our input resolution, our aspect ratio, frame rate, YUV, as I said, chroma subsampling. Pretty good, pretty good. But now let's start doing some real fun stuff and start building videos with Python. So MoviePy, as I said, is this excellent library that's come out that allows you to really do some crazy stuff. I want you guys to be able to walk away from this talk, and I mean, even if you just have two videos that you want to connect together, you don't need to go looking anywhere to download any sort of like video editor. You can do it yourself using Python and FFmpeg. So pip install MoviePy. So this is from their documentation. This is a general layout of how it works. You give it some clips, FFmpeg reads it, then you can use NumPy, SciPy, OpenCV, or the Python imaging library, as well as GIMP and ImageMagick, and a couple other. I think those 6 are it. But use those things to compose different images, to change what's going on, to add some effects to your video, and then the output is all sewn together with FFmpeg. So another note on MoviePy is that it has some of the nicest inheritance I've ever seen. Like if you are looking for something to just show you, like, I want to see like what's a good way of like using a lot of objects to inherit from one another and to show you some really good object-oriented programming, like really excellent. Take a look at it. Have some like a beer or something night, sit down, just read the source code. It's really nice. And it gives you some excellent time to like see what all these different clips do. So I say clips. So in MoviePy, everything is a clip object. So here's like a canonical Hello World example. This would just make a black box that just says Hello World. But that's 3 lines of Python, and it's a video. It's a 10-second video that you got just from 3 lines, plus the entire library that you imported. Hey, it worked. Yeah, this is your video. The CSS is a little bit funky with it, so it's not going to play. But yeah, this is the video that you would create with that. So let's take it a step further than that. So you're making a video, and you want to generate some kind of graphic elements. Why not just make a script to do that? Why not, let's say you're doing a show about like celebrities and you want to just get a bunch of tweets together. Why bother like downloading these tweets and like having to edit these tweets together and have to copy and paste text? You can just write a script for that. So again, big thanks to Zuko. So here we go. This is our array of tweets. Again, you can see here. So the way MoviePy works is you import the editor, and then from the editor, you can create your clips on it. So if you do come from a world of movie editing, I kind of think of the editor as like your sequence at the bottom that holds everything, and then these modules are stuff that you apply to your sequence, and arguments too. So yeah, here we go. Our aggregator collects tweets. For tweet in tweets, we create a clip of it. Super easy. And then we put those tweets together using the composite video clip, which will then hold all of our smaller clips and concatenate them and write them out to a file. Super simple. And does this stuff look at all familiar to you guys? You'll notice that Zuko uses the V codec flag instead of C:V for codec, but it works the same. That flag has been around longer and it still works. As I said, that's kind of like part of the intricacies of FFmpeg, that it's just been around for a long time and it can kind of do some weird things. But yeah, besides that, everything else here, like this is the size, pixel format, everything here is like it's an output file. Like, it's great. So this this is an example of like a script that would take in a quote and an author and give you back in a file size or a resolution also, and then return to you a element of just whatever you wanted. Like like the yellow background is what I chose, and then I chose to kind of have it a little off center. We'll see if it plays. And then this is a little Flask app that would take a author and quote from a post request, and you can feed it some codecs, and it'll encode for your codec, and then it'll put it in your static file, and you'll have it in your context. So it'll just create the file for you. I'll just create the web page, and yeah. Very, very doable. I'm not going to go into how to do that here, but very, very doable. That is definitely something you can do. So this is the video that would play, but the quotes over there, you see, the attribution. So, okay, that was a big reveal. So if you want to see, I made another version of it. So that was like a couple lines. This is more complicated, but it just takes James's Twitter profile picture and makes like a nice tile on the background, and then gives all his tweets one by one, and it makes a slideshow out of it. So yeah, exactly to your point about like putting a soundtrack over a GIF, like or over a string of GIFs, totally doable. And yeah, you can check out my code. This is my GitHub page, so if you want to just go to it, and the code is hot linked to it. And yeah, one of the coolest projects is this thing. Well, there's two really great ones right here. So there's Video Grep, which will search subtitle files, and then create supercuts out of that. So if you ever seen like The Daily Show or something where they're like, look at everyone on Fox News saying the same thing, that's what you can do using subtitle files, MoviePy, and Video Grep. And then RinconCam is, so someone set up a way to monitor surfers, and so this entire video, so he wrote an OpenCV application that would find the surfers and then move the camera to the surfers and follow them, and then he wrote another program to search through like days of footage and find the keepers, and then it edits the video using MoviePy, and then MoviePy creates the clip, exports the clip, and sends it out every day. So instead of having someone watching surfers for 12 hours and having to go through all that footage and editing it together, literally programmatically is able to do all this. So it's a really powerful program. And that source code isn't online, but I would like it to be. It's a cool project. Bug the guy. Yeah. And so this is all just FFmpeg stuff. I only have 5 minutes left, so if you guys have any questions, I'd love to hear them.
I was a little late, pardon me. Did you talk about FFmpeg?
I didn't. I don't know about FFmpeg.
Well, it's like downloaded right next to FFmpeg, and it's fantastic because it gives you like use it to like basically analyze any video file and get like sort of stats on any video file.
Okay.
And it'll output as JSON.
Oh wow.
So like you can, if you want to like, I was working for a video company for a while, and you could like analyze other companies' products to see if they're like,
yeah.
Deciding what your settings are, because you see, like video, so check out how they do their configuration. It's really rad.
Yeah.
The other thing is that there's a branch of FFmpeg. Are you aware of that? Like
libav, yeah.
Right. And sometimes you'll get it'll tell you that FFmpeg is deprecated. You should use libav. It's sort of like there's a video war going on.
Yeah.
Between, personalities.
Yeah.
And FFmpeg is still active. And the guy who did it, I think, learned some lessons from this,
Yeah.
And like this like stepped up the improving the way you work with people. But the other thing is also a totally viable branch.
Okay.
It also has it's got different things, but FFmpeg does pull back in from with
Yeah.
so
Yeah.
he's bringing back in, but they don't bring anything over from FFmpeg.
Yeah.
I just wanted to throw that out there.
That's a very good point. Yeah. When compiling FFmpeg, it's important to have like all the dependencies, including libav. And also, so I mentioned media info is a tool that I use, but it sounds similar and doesn't do JSON, which sounds really cool.
So with this movie if you already have like a movie, could you take it from movie and then do like filter or like any kind of
Yeah.
editing on that as well?
Yeah. So you don't have to just create stuff from scratch. You can take in video. Again, look at the source. Like a video clip, you'll just pull it in. They have a reader module that's really nice. For both like looking at how FFmpeg works and for looking at how MoviePy works, it's a really great thing to do. Just look at the source.
For the is that also
It is. It's based on OpenCV. Yeah, that's as much as I know about that. Cool. Thank you all very much for coming.